Right, third subtopic, which is on resistance, reactance, and impedance. Okay, so in this subtopic, you have to be able to sketch and use phasor diagram and sinusoidal waveform to show the phase relationship between current and voltage for a single component circuit of resistor, capacitor, and inductor. Use phasor diagram to analyze voltage, current, and impedance of series circuit of RL, RC, and RLC. So, and then you have to be able to define and use capacitive and inductive reactance, impedance, and phase angle. Lastly, explain graphically the dependence of resistance XC, XL, and Z on frequency and relate it to resonance. Alright, so what is a phasor diagram? Phasor diagram basically a diagram that contains a phasor lah. Tapi what is phasor? Phasor is defined as a vector that rotate anticlockwise with constant angular frequency. So dia sentiasa constant lah. So phasors ni adalah digunakan to represent sinusoidally varying voltage and current. And lastly, it is used to also determine the phase angle, which is the phase difference between current and voltage in alternating current lah. Okay, right. So let's look at this one. This is an example of a phasor diagram lah. This is a phasor diagram. This is your sinusoidal AC waveform. Okay, so basically what this tells us is whether, for example, if this one here is voltage, this one here is current, it's telling us that the current is leading the voltage by 90 degree. Okay, so this is 90 degree kan? Okay, so this here is your phase angle, right? Okay, so the length of this phasor ni, which is this one here, is gonna be equal to the maximum current lah, ataupun maximum voltage. And it rotates with frequency and angular speed omega. Yeah, that's basically what you need to know lah. Alright, so this is the vector rotation. So that's why I know it's 90 degree here. And then if it's here, it's 30 degree. But it's not really necessary for you to remember this. But this is just what you need to know lah. Okay. Right, so let's look at pure resistor in AC circuit. So this bit is a bit long lah untuk this subtopic. Okay, so for a pure resistor in an AC circuit, their connection is just with a resistor. Okay, so the current in the resistor is given by this, and this is the voltage punya. Oh, I forgot. Oh, okay, I did something wrong here. This is pi f. 2 pi f. Right, let me just see that in my original notes. Yeah, I did something wrong here. Okay, so now wait sorry everybody. Alright, so this one we know that omega is equal to 2 pi f and v naught is going to be equal to I naught darab dengan the resistance itself. So untuk pure resistor, the current and voltage are going to be in phase. So basically they are rotating together at every angle lah. Okay, so the current and voltage are in phase, meaning that the crest and troughs occurs together. Okay, right, so both V and I, okay, so basically when they are in phase, the minimum and maximum value occurs at the same time lah. Alright, so when we apply Ohm's law, we can actually calculate the instantaneous power delivered to the resistor. So this is for pure resistor lah, okay. So ini adalah equation untuk pure resistor. Right, so untuk the average power pula, ini instantaneous power. For the average power, it will be half of the peak ataupun maximum power. Right? Alright. Okay, that's basically that. This is a graph of instantaneous power being absorbed by the resistor against time lah. Okay, so at this point here, at this peak power, the power is being absorbed. Yeah, okay, so I don't really have to explain much on this. You just have to kind of read it through. Okay, so basically the average power for pure resistor you can calculate using this, where R is the impedance, and then the impedance for pure resistor is basically equal to the resistor itself lah. Okay, right, now for pure capacitor pula, so this is when an AC source connected directly to a capacitor. So we know that the charge will be accumulated on the capacitor plates, which is given by this equation here. Okay, remember VC, this is voltage for across the capacitor lah. Then the current flowing in the circuit will be given by the rate of change of charge. Okay, so when we do that, differentiate it, we'll get an equation that looks like this. And then we know that C V naught W would equal to the peak current. So we can then let it equal to this equation here. Okay, so basically that's just how they get the equation lah. Okay, tapi kalau kamu tengok untuk pure capacitor, dia punya equation is in cos, okay, instead of sine, right? But then actually you can also do it in terms of sine, but you just have to consider the phase angle here, right? So basically this is telling us that the cos dia sudah start dengan peak at the peak, so this one dia just tambah satu ni supaya dia bergerak macam ni. Instead of macam ni, dia akan jadi begini. Okay, so this is, dia boleh guna sine tapi mesti tambah phase angle di sini, right? I mean tambah the phase angle lah, okay? Right, and then we have the phasor diagram for a pure capacitor punya circuit. As we can see here, the current leads the voltage by 90 degree ataupun by pi over 2 radian lah. Alright, so yeah, if you look at this, kalau kamu tengok di sini, kita dapat cos di sini sebab untuk current ni dia sudah start at a value. Okay, it doesn't start from 0, so that's why it is cos. Okay, right. Right, so when the current leads the voltage, when the current is at maximum, the voltage is gonna be 0 lah. Okay, so the instantaneous power untuk pure capacitor is given by this equation here. And then for the peak power, it's basically this one. And then, yeah, basically this is the instantaneous lah, right? Ay, miring juga to. Okay, so the average power for pure capacitor will be equal to 0 lah, sebab a pure capacitor, and then a pure capacitor does not dissipate energy, right? Okay, so again, that's just the graph of instantaneous power against time. Okay, for impedance in a pure capacitor pula, it is not equal to C, it is gonna be equal to the capacitive reactance. So what is this capacitive reactance? It is the opposition of a capacitor to the alternating current flows. Okay, so sama juga lah macam dia resistance. Dia measure, dia kiranya dia block lah from flowing kan. So it's the same thing as capacitive reactance, but this is for capacitor, right? So dapatlah this equation here, that is the impedance of a pure capacitor, and the SI unit is going to be in ohm lah. Okay, so how do we calculate the maximum voltage across the capacitor? We'll be multiplying with XC, not with C ataupun R. Okay, so kamu kena darab dengan XC lah. Alright, so it can also be expressed in terms of RMS value, so it's just going to be VRMS, IRMS, XC. Okay. In general, the voltage across a capacitor can be calculated using this equation here. Okay. Alright, tapi V dengan I ni dia RMS lah. Kamu ingat yang tu je. Okay, so if you look at the relationship between the capacitive reactance and frequency, the reactance will be very large at low frequency, and then the reactance is very small at higher frequency. Maksudnya diorang indirectly proportional. Okay, so now let's look at pure inductor. Okay, so for pure inductor, this is the equation for the current. So this ni dia guna sine lah masih. Okay, and then since we know that the current is changing with time, self-induction will occur in the inductor, which induces a voltage known as back EMF. So back EMF ni, according to Faraday's law, we know that it is the rate of change of current lah. Okay, darab dengan the self-induction. So kita dapat satu equation yang macam ni lah. Okay, so at any instant the supply voltage will be equal to the back EMF, tapi the direction will always oppose to the supply voltage, that's why dia ada negative di situ. Okay, alright. So negative sign tu maksudnya dia bagi tahu kita direction back EMF tu sentiasa berbeza dengan di supply voltage lah. Alright. Okay, so now we can let this equation here become V0, so that's why we have this equation here. Okay, so sekarang dia jadi cos, that's why kita tambah pi over 2 supaya kita dapat tukar jadi sin lah. right? Okay, so this is the phasor diagram. Sekarang ni kita tengok voltage leads the current by 90 degree. By 90 degree lah, okay? So this is the graph of variation of voltage against time lah. Alright, okay. If we look at the graph, we can see that when the voltage is at a maximum, the current is going to be equal to 0. Kenapa? Sebab kalau kita tengok sini, voltage leads current by 90 degree. Okay, begitulah relationship dorang. So the instantaneous pula is given by this equation here. It's the same as the previous one. And the average power is also equal to 0 because a pure inductor does not dissipate energy lah. Okay, so the impedance in a pure inductor pula, kenapa dia tukar PN ya? I feel like I didn't write N, but dia keluar N. Okay, so untuk the impedance pula, dia akan jadi inductive reactance. Okay, nama dia tu kita panggil inductive reactance, which is this one here. So it will be equal to 2 pi FL, right? Okay, so the SI unit is again ohm, and then the maximum voltage cross inductor sama juga lah, boleh calculate guna ini. Can be expressed in terms of RMS value, and the voltage across inductor is this one here. Okay, so always remember the voltage across the inductor, capacitor, resistor semua tu berbeza. Okay, supply voltage tu pun berbeza. Okay, right. So sekarang ni kita tengok relationship between inductive reactance and frequency. We can see that they are directly proportional, right? Okay, so basically this is a summary for pure resistor, capacitor and inductor lah. So untuk pure resistor, V and I in phase, capacitor I leads V by 90 degree, inductive V leads I by 90 degree. Okay, so that's just a simplification of what we've learned just now lah, right? Okay, so let's look at example number 2. We have a capacitor with an RMS current of 21 milliampere. Okay, lepas tu ada frequency 60 Hz. When the RMS voltage across it is 14 volt. So sekarang ni across it a capacitor. Ini adalah VC lah, which is 14 volt. So what is the capacitance of the capacitor? So for this one here, we are going to use the capacitive reactance formula 1 over 2 pi FC. So what we are looking for is the value of C. However, we do not have the value of XC. So how do we do this? We know that VC is going to be equal to I XC. So XC is equal to this is basically our IRMS sama juga tu. VC over IRMS. So dapatlah the value of capacitive reactance. So this is 21 milli. So you will get 666.67 ohm. Right, so that is the capacitive reactance. So substitute that into the formula here supaya kita boleh cari capacitance of the capacitor lah. Right, so 2 pi F is 60. XC is 666.671. So kamu akan dapat the capacitance of the capacitor to be equal to 3.98 microfarad. Okay, so kalau kamu ada beza by decimal point tu je, tidak ada masalah juga lah, tapi jangan terlalu berbeza. Okay, question B. If the frequency is increased, will the current in the capacitor increase, decrease, or stay the same? So, untuk capacitor, we know that the capacitive reactance is inversely proportional to the frequency. So, kiranya bila frequency increase, capacitive reactance will decrease. So, what is the relationship of capacitance and current? It is also inversely proportional. So, bila capacitive reactance decrease, current will increase lah. Okay, so jawapan dia increase. Explanation there is basically this one here lah. Okay, kamu explain. Right, so that is the solution for question B. Calculate the RMS current at a frequency of 410 Hz. So sekarang kita perlu cari IRMS. So we know that we can use VC over the value of XC. Okay, so sekarang kita perlu cari apa? Kita perlu cari the value of XC, tapi kita sudah kila pula. XC kita perlu kira balik sebab the frequency change to 410. And then berapa value C tadi? 2 pi FC. Mana tu? 3.98. Okay, so kamu akan dapat the capacitive reactance to be equal to 97.53 ohm. So, bila kita substitute dalam sini, RMS, VC is, cross capacitor is 14 divided by 97.53. Kamu akan dapat 0.144 ampere. Alright, so that is example 2. Example 3 pula. Okay, so for example 3, we have an RMS voltage of 12.2 with a frequency of 1 kilohertz. So that is 1000 lah kan. Applied to a 0.29 millihenry inductor. And then what is the RMS current in the circuit? So the RMS current in the circuit, kita akan guna VRMS, IRMS. This is our pure inductor kan? Yeah. XL. Pure inductor kan ni? Yalah, tiada resistor dia siapa kan? So dari sini kita perlu cari IRMS equal to VRMS divided by the inductive reactance. But we do not have the value of inductive reactance, so just calculate it. And this is 1 kilo. -3. Okay, so kamu akan dapat the inductive reactance to be equal to 1.82 ohm. Okay, so bolehlah substitute. VRMS is 12.2 divided by 1.82 equal to 6.7 ampere. Okay, lepas tu apa lagi? Ada lagi dia minta? Betul lah, 6.7 ampere kan. Right, lepas tu determine the peak current for a frequency of 2.5 Hz. Oh, this one saya sudah tambah di nota tapi saya belum update di sini. So 2.5 kilohertz lah. Okay, so this is 2.5 kilohertz. Now we are gonna find the current, peak current kan. Tapi sekarang untuk cari peak current, kita perlu di RMS current. Okay, so untuk cari RMS current, kita perlu cari di inductive reactance. Inductive reactance yang dia sudah tukar frekuensi itulah, okay. So this is 2 pi FL kan. So F kita guna 2.5 ribu. And then 2 pi FL, L is 0.29 milli. VRMS tadi berapa? VRMS 12.2. So kamu akan dapat the RMS current to be equal to 2.68 ampere. Okay. That is the RMS current. So sekarang baru kita substitute untuk cari peak current. So kamu akan dapatlah the peak current to be equal to 3.79 ampere. Alright? Alright. That is the solution for example 3. So I'm going to cut this video here just so that this video is not going to be too long. So I'll continue in the next video.